which are the highest filled materials, let's say. The problem is with bigger particles, let's say with pre-polymerized fillers. They are of polymeric origin somehow, the surface. And then we come back to hydrolysis and silanization of the fillers. Well, nanoparticles, this is a different research, silanization of nanoparticles. But once they are good silanized, they have a good interface. And this is a problem with the pre-polymeric fillers because they cannot be silanized in that way. And we do see a lower fatigue resistance for these pre-polymerized fillers. And more materials coming up to the market. There must be a patent somehow. Yeah, that's right. What I wanted to say with hybrid materials, let's say if you have a filler size of 0.5 micron, 1 micron, 1.5 micron, there is a critical size of a defect which releases a crack to grow at a certain stress. And 1 micron, 1.5 microns are still far below the critical sizes for this kind of materials. If you would, let's say, if you have a particle which is 20 microns in size and which is irregularly shaped at the surface, so this could influence the strength in terms of a big particle reduces the strength. But these particles all are below the critical sizes for the fracture releasing influence.
I thought the idea for using hybrid material is to have the particle size very different, so the small ones fills the voids that the large ones left behind. So in this case, may give you beneficial effect.
Exactly, exactly. They fill the voids, and also you get less stresses in the polymer. The polymer, we all know there is a shrinkage. There's a shrinkage stress coming from the polymer, not only at the surface, also around the small filler particle. And the more particles you have inside, the less stress inside the matrix you will get.
You showed at the beginning of your presentation paper, I think by the Dutch people, about clinical failures, among which fracture was 17% and Carey's activity was about the same. The fracture mainly are from hybrid composites, not from nano-filled composites.
Mm-hmm.
Do you have any evidence in the literature of the failed fractographic surface of these fractures of composites, and how do they relate with your fatigued in vitro specimens?
Mm-hmm. This is a very good thing. You don't even find from clinical studies when a special restoration failed. You do not find this information. You should find it in a clinical study. It failed after 2 years of service, after 5 years of service. How many restorations failed after 5 years, after 10 years? This is a very important information for us as material scientists, but you don't get this information. I haven't seen fractographic evidence for resin composites. I have seen for ceramics, well, but not for resin composites. That's a pity. And I agree, these are old materials, and we have today different adhesive systems and different resin composites which are more resistant to crack, to fatigue, and whatever. So might be different today.
I have one question for you. There are some papers showing that pores or bubbles, I don't know, from within the resin composites are a problem. And since you showed many fractographic pictures here today, and I saw a pretty big pore on one on the right here, the one that had the larger particles. So I would like to know if you, since you did a large fractographic work here, did you see pore as a problem, and especially related to fatigue of these materials in the fractographic analysis?
Well, once there are too many pores, of course, it's a problem. But a pore itself has a very perfectly round-shaped appearance. It's not there are no sharp edges like that. It's not that dramatic as it seems from a fractographic image once you have a lot of pores. And even this pore was far away from the tensile zone, so I don't think it's influencing. And we always, if we do a test, let's say strength or fatigue, we afterwards look at the fracture surfaces, and we see, for example, materials with a high strength, we look, and there are so many pores inside. And there, we have the feeling there is not a real correlation once there are not too many pores inside, of course.
Okay, any other question? You can also ask questions to the rest of the audience. Okay, so thank you, Ulrich, very much.
Thank you.
We now have a 20 minutes break, so what time is it now? So we'll be back here at 10:50 for Bob Kelly's lecture, and after that we go for lunch. Thank you.